A company makes two sizes of boxes shaped like rectangular prisms. The large box is 16 inches tall, 10 inches wide, and 10 inches long. The drawing shows the dimensions of the small box. Okay, so we see the small box shown here. Two-part question, so let's focus on the first part. What is the maximum number of small boxes that can fit inside the large box? I'm going to go ahead and read part B too. Part B says the company plans to increase the width and length of the large box by 4 inches to create a new larger box. How many more of the small boxes will be able to fit inside this new larger box compared to the original? Okay, that's even more information. I'm going to take it back to part A. And we just need to find what is the maximum number of small boxes that can fit inside the large box. So this is working with a concept that'll be new for us called volume. And volume means how much space there is inside of a 3D object, okay? So whereas area is how much space there is on a flat surface, this is a 3D object. We're talking about how much space is inside it. You can think about it like how much water could you fill it with, okay? And the formula for volume of a rectangular prism is length times width times the height. So our overall approach is going to be to find the volume of this large box shown by these dimensions and then divide it by the volume of this smaller box indicated by these dimensions here and see how many of these small boxes will fit into this larger box. Alright, so let's find the volume of, we call it VL. It's going to be the volume of our large box. It's going to be 16 inches by 10 inches. Alright, 10 inches. And 16 times 10 is going to give us 160. Then 160 times another 10 is going to give us 1,600. Now what about the inches here? Inches times inches times inches. That's inches to the power of 3. You can also call that cubed, inches cubed. Alright, so we got the volume of the large box. Excuse me, that's the small box. The large box dimensions were up here that we just found. Okay, let's find the volume of the small box now. It's an S for small box. It's going to be 4 inches times 2 inches times 2 inches. Which is going to be 4 times 2 is 8, times 2 is 16, so it's going to be 16 inches cubed. And now they want to know, that's the volume of our small box, how many of those would fit into our large box? Well, we can just divide our large box by the size of our small box. So it's going to be 600 divided by 16. That'll tell us how many of these go into our large box here. 16 goes into 16 one time. 1 times 16 is 16. Subtract it. 0. Bring down to 0. 16 does not go into 0. It goes into it 0 times. Then we still have another 0 to bring to 0 times 16. That's 0 again. Bring down the next 0, the last 0. 16 goes into that 0. Also 0 times. And our decimal is right here. And for me personally, whenever I end up having a lot of zeros, I always just make sure that I did it right. Let me make sure 16 times 100 is 1600. Yeah, 1600. Yes, that's correct. 1,600 divided by 16 is 100. So that's our part A. 100 small boxes. All right, part B. Company plans to increase the width and length of the large box by 4 inches. Okay, so this is going to change the volume of the large box. They want to know, once we do that, we increase the width and length by 4 inches each, how many more of the small boxes will fit. Okay, so initially we fit 100, so we'll keep that in mind. Let's find our new large volume. Volume, say, our new large volume. It's even larger, and that's going to be the width. Add 4 inches to it, so instead of 16, let me be mindful. Let me go back up to what the chart said here. For here, I mixed up the order, and it didn't really matter a whole lot because we're multiplying them all together anyway. But now I need to be a little more particular. It says the width has 4 inches added to it, so this is now going to be 14. Okay, it's going to be 14. My width is going to be 14, and the length also changes. So the length is also going to be 14. And the height was unchanged, so that's still going to be 16. Okay, so let's multiply this out now. So we have 14 by 14. It's going to be 196. Then 196 times 16. Multiply that. 6 times 6 is 36. 6 times 9 is 54. Plus 3, 57. 6 times 1 is 6. Plus 5 is 11. Start a new row. Okay, so our new larger volume is quite a bit more once you multiply that all out. So I'm going to make some space here. All right. So now we need to see how many of the small boxes again go into this new larger box. And we'll see how many more that is as compared to before, where it was 100. 3, 3, 1, 6. Let me make that a little brighter. We have 3, 3, 1, 6 divided by this smaller volume, which was 4 times 2. Should have written this over here. 4 times 2 times 2, which is 16. Okay. So we're dividing this value by 16. 16 goes into 32 2 times. 2 times 16 is 32. I think I just misspoke. I should have said 16 goes into 33 2 times. 2 times 16 is 32. 16 goes into 11 0 times. 16 goes into 116. 10 will be too much. Let's try like 8. Still a little too much. Let's try 7. 7 will work. and it's 207.2 something. And it's going to be a decimal, so they wanted to know what is the difference going to be. So these decimals aren't really they're not going to count because those are not full amount of boxes that fits. So the other one fits 100 boxes. This one fits 207 boxes. You can't really cut the box into little pieces and add in 0.2 of a box. So it's going to be 207 boxes as compared to 200. So 207 compared to 100. 207 minus 100 is going to give you 107. So how many more smaller boxes will be able to fit inside this new larger box? It's 107 more smaller boxes